be taking. Okay, so we are rolling. Let's go ahead and get started. Ask me later. Let's get started.
You're gonna act fake now?
I'm gonna try to act the way I always act.
How's your day?
My day's been good, Nick. Go ahead and take a seat. Let's get started. So, just to get started while I take attendance, I want you guys to compute these values for me. I want you to find for me. It's a little loud in here. I want you guys to find for me cosine of 165. And I'd also like you to find for me tangent of 15 degrees. Sound good? So just as a quick reminder, in order to find these, we're going to use those formulas that we learned on Tuesday, right? We were live yesterday? Okay. So you're going to need to find some combination of angles that we already know on our unit circle that will give us 165. Then just simply plug into that formula and you'll be good. Here you'll need to find two angles we can combine that we already know to give us 15. Use the unit circle to find the values, plug into that formula, you'll be good. Sound good? Okay, you should be able to complete this in 5 minutes. Okay then. Okay, so attendance, Thomas. Okay, Nicole. Adrian. Pamela. Erica. Ravina. Deshauna. Solander. Selena. Kay. Anisha. Chanel. Oh, is that box empty? Is that box empty? The tissues. Oh, no. Nick. And Kara.
I mean, it's funny. You're gonna go search the signs and maybe put tissues over there. Okay, narrow. Okay, stop, guys.
What's that? Yeah. Actually, the things we're covering today, you need to know in order to get this stuff. Pass these out. Yes, it is. It will be recording the whole time. Okay. So, we have cosine of 165. What are two angles we could combine to get 165?
120 and 45.
120 and 45, that's one combo. Any others?
135 and 30.
135 and 30, that'll work. Any others? Oh, 120 and 45. There we go. Are there any others you can think of?
Yeah.
You can also kind of do some subtraction stuff. You could do like 210 and 45. But let's just go ahead and go with one of these. Which one should we go with? The 120 or the 135?
135.
Let's go with...
135. 120.
I'll go with the first one.
Yeah.
Okay, so I'll need to rewrite this as cosine of 120 plus what?
Plus 45.
Plus 45. Of these two numbers, which one is alpha? Or which one's beta? Does it matter which one is which? Man. Okay. So I'll need to so which formula will we use? Which of these many formulas will we use? That very first one up there. So we'll need to have cosine of 120 times cosine of minus sine of 120 times sine of 45. Cool. So what is sine of 120? Oh, sorry, yeah. My apologies. What is cosine of 120? Yeah. That's a negative half. And what's cosine of 45? Root 2 over 2. We're subtracting. What's sine of 120? That's a positive root 3 over 2, but I mean, still a negative sign there. What's sine of 45? Okay. Root 2 over 2. Okay, so now we can just kind of combine these guys together. Negative 1 over 2 times root 2 over 2. That's a negative root 2 over 4. And square root of 3 times square root of 2? That's square root of 6 over 4. Okay. we can combine them together to get a negative square root of 2 minus square root of 6 over 4. Can we simplify this any further? Okay, raise your hands if you got this mostly right. So, it's worth noting that the order of these doesn't matter. If you got square root of 2 or negative square root of 6 minus square root of 2, that's also correct. So, out of curiosity, raise your hands if you did it with 120 and 45. Raise your hands if you did it with 135 and 30. So, there's more than one way to get this right.
I had a different answer.
Did you? What'd you get?
Positive root 2 plus 3 over 4.
Positive root 2 plus 3 over 4?
Yeah.
I don't think that you... I think that there was a mistake somewhere in the math. Let's take a moment and do that. And just check that. Really, really fast. So in that case, it's going to have 135, a 30, a 135, and a 30. Yeah? Cosine of 135 is root 2 over 2. Or, yeah, negative, yeah. Negative root 2 over 2. Cosine of 30, that's a root 3 over 2, actually.
Oh, okay. Never mind.
You found it?
I used 150 degrees instead of 135.
Ah, so you looked at the wrong spot in your
Yeah.
unit circle. Okay. But if we actually can just continue for just a moment and fill this out, then that would be sine of 135, which is root 2 over 2, and sine of 30, which is 1/2. Hey, look at that. We just got the same thing. Both answers, or both paths, will lead us to the same result. Okay, now for tan. What numbers can we combine together to get 15? We can do 45 and 30, but instead of adding them, we will have to subtract them. So we can rewrite this as tan of 45 minus 30. So we'll have to use that very bottom formula. Let's see, so I'll have to have tan of 45 minus a tan of 30 all over 1 plus tan of 45 times tan of 30. So, well, I guess we'll need to find out what tan of 45 is. What's tan of 45? How do you do that? Yeah, it's sine over cosine. Sine of root 2, of 45 is root 2 over 2. Cosine is root 2 over 2. Anything divided by itself is 1. Okay, now for tan 30. I'm going to call on somebody to help me out. So, Erica. So, we know that tan of 15 is going to be the y over the x, right? Okay, so what's the y at 15?
Half.
Or sorry, not 15, 30. Yeah, so it's going to be half. What's going to be on bottom? Square root 3 over 2. Okay, so how does this simplify? What do we get?
Multiply
So you're going to, what do you mean by that?
the bottom to the top.
So we're going to move the bottom to the top and do what as it moves? Yeah. 2 over root 3.
And then the 2's the 5.
The 2's cancel out, and we're left with 1 over square root of 3. Good job. So, if we want, we can leave it like that. Or we could rationalize it, multiply top and bottom by square root of 3 over square root of 3. And we'll end up with our final answer of 1 minus square root of 3 over 3 on top. And 1 plus Square root of 3 over 3. Fair enough? How'd you guys do? Raise your hand if you did okay. I'm probably going to need to spend more time on this, but not today. We got a lesson to get done. So our lesson Tuesday was all about, it was very algebraic, right? We spent a lot of time looking at formulas and using formulas. Today we're going to be doing something a little differently. Today we're going to be spending most of our time looking at graphs. So I need everybody to either get out a calculator, or if you want to use Desmos, you can use Desmos. So go on, come and get it. We'll be, just as a heads up, while you guys are getting your materials here, I will not be here tomorrow. Oh. You're breaking my heart, Adrian.
What are we doing tomorrow?
You guys will be working on a worksheet covering the material we're going to be doing today. I'm going to be sitting at a mechanic's place. The muffler fell off my car. Okay. So, let's go ahead and get down to business. Today you will be needing your notebooks, not your workbooks, your notebooks. And you will be using those calculators, pencil, that's all we should be needing today. Go ahead and copy down the title and objective of today's lesson. Today we'll be talking about the structure of trig functions. And our objective is to be able to graph a trig function given its equation. Okay, so we'll be using Desmos. Cool. Okay, let's go ahead and get started. Now, the first thing that we need to do is we need to make sure that our calculators, our graphers rather, are in the correct mode. So go ahead and turn on your calculator. Those of you who are using Desmos, go ahead and load up Desmos. I'll be teaching to both for both of you guys today. Both groups, those using Desmos and those using calculators. Now, we'll be doing stuff in trigonometry. Now, in angles, when doing trigonometry, working with sine and cosine, we can use both degrees and radians, right? So we need to decide whether we're going to be working with degrees or radians today. But for the purposes of this lesson, we're going to be working in radians. But we need to tell our calculators that. Calculators are pretty stupid, so we need to tell them what we're doing. So those of you using the TIs, the TI-84s, go ahead and press the mode button. You see it on the top row of the black, just to the right second. Go ahead and press mode. And you should see a whole list. This is basically the settings menu for the calculator. And you see how the third line says radian and degree? Make sure that radian is highlighted. If radian isn't highlighted, then go down there, select radian, and press enter. Okay, sound good? Raise your hands if your calculator is set in radian mode, if you've done that. I'm going to go around and make sure everybody's where they need to be. Those of you using Desmos, you see the wrench on the upper right corner? That is the settings mode for Desmos. And on the bottom, you'll see radians and degrees. Go ahead and click on radians. Sound good? Okay, so let's go ahead and start. Oh, one last thing. Almost forgot. Now, I also want us to have the graphing window set to a convenient zoom level, something that's useful for trigonometry. So those of us using the TI-83s or 84s, see the zoom button on top? Let's go ahead and press that. This has a whole bunch of different preset zoom sizes for your window. The default is 6, standard, but we're going to be working in trigonometry, so which one do you think we'll need to click on? Number 7, which is Z-trig. You can either go down the list to it, or just press 7. There. That'll change the zoom level.
What do we do?
Okay, what we're doing is we're changing the zoom level so it's set for trig.
So when I go,
So press zoom, then select Z-trig. Those of you using Desmos, you can just pinch to change the zoom level. Yes, sir. That looks good to me. Okay, so all I'm doing here is just changing the zoom levels. Okay, cool.
I can't even see.
Okay, so let's go ahead and get started. Let's get graphic. Focus. Okay. So what we're going to do today is we're just going to experiment with the graph of sine. We're going to try just doing things to the graph and see how it changes. How do changes to the equation change our graph? And hopefully, from doing this, we should be able to figure out some general rules for the equation of a sine wave. Sound good? Okay. So let's go ahead and start by graphing sine of x. Y equals sine of x. Like that. No changes. So, those of you using our calculators will go to our equations by pressing y equals. If you already see other equations there left over from the other class, go ahead and just select them and press clear to erase. And for the rest, we need sine of x. Where's the sine button?
above the comma.
It's the one above the comma, in between comma and apps. There's sine. Yeah. And how do we press x? What's x?
It's next to alpha.
Yeah, it's that one just the right of alpha, the one that says x, t, theta, n. There. You can also press alpha x, but that's an extra keystroke. Who needs that? Then close it, then make sure to use the right parenthesis to close it, and then press graph, and you'll see the graph of the sine wave. Sound good? Now those of you using Desmos. So, we'll just press y equals, where's sine?
Spell it out.
You could spell it out. There's actually more than one way. Desmos is smart enough to know what you're talking about if you go to the keyboard and just type sine. But if you press funcs, then it'll have a whole list of functions already there. Go ahead and just select sine, and there it is. Sine of x. Close the parenthesis, and you're good. And you'll see the sine. Be good? Okay, I'm just going to go around and make sure everybody has a sine wave. So I'm going to walk past. Go ahead and hold up the screen at me. Show me what you got. Right there, good. Looks good. Okay. Uh-oh. Oh, you just press graph and we'll bring it up. Yeah, so once you type in the equation, just press graph. There it is. Okay. Alright, what do you calculate? There you go. I do this. That's just the general calculation though. So you want to go to work. Go ahead, type it out.
Okay, fine.
Sine. Now go ahead and close it. There, and you put okay. Yeah. Cool. times. So can you go ahead and grab it here?
You've been practicing
Now, go ahead and grab side by side. I just want to make sure everybody's on the same page. So where do we print the equations?
Where? I said they fell Soy uno de soy uno de IC. Got no IC.
Right, press C. This is what that.
Oh, it's the computer.
Got no IC. Nuggets.
Okay. So let's go ahead and discuss what we now see on the screen. We have, I think, 3 people in here using Desmos. So most of us are using the calculator. So I'm going to make a drawing of what the calculators show on the screen, and we're going to go ahead and discuss what we see here. Sound good?
Yeah.
Okay. My day has been fantastic. Thanks for asking. Okay, so here we see our screen. Now, what's the wave doing? What's our sine wave actually doing? So it's wiggling. Okay. So in the center, as we go to the right, is it starting by going? Where is it starting? First of all,
It's starting from the origin.
starting around the origin. Then is it going up or down?
Going up.
Up. Okay. So it's going to go up, and then down again to here, right? Then down, and back up. And it's doing the exact same thing over here on the left. Just okay, like that. Okay, it is a little too loud in here. So, I swear, I put my hands down and everyone just starts talking. So, how far to the right does this graph really go? It just keeps on going forever, right? How far to the left does it go? Okay. So, now on this screen, when in Zoom Trig, there are a bunch of different zoom levels you can use. You can also set your own zooms. But when in Zoom Trig, each of these tick marks on the vertical axis is 1 apart. So it goes 1, 2, 3, and the top of the screen is 4. Going down, it goes -1, -2, -3, -4. Fair enough? Now in trig mode, each of these tick marks is a half pi. So we're going from 0 in the middle to 2 pi on the right side to -2 pi on the left side. And each of these ticks is a half pi. Then -pi over 2, -pi, and -3 pi over 2. Fair enough? Okay, so the graph of sine, we can kind of see a few features. We see the high spots here, we see the low spots here. We need a name for these features. What do you think we should call the high spots? Any ideas?
Range.
The range? The range means all the different possible y values that we can get as a result. So the range includes everything from -1 to 1. Yeah. But what should we call this spot right here? What should we call these spots on the peaks?
Oh.
Oh,
What's the name of it? It starts with M.
you're thinking of a maximum?
Yeah.
Yeah, well, we'll go to refer to these just as peaks.
Oh, okay.
Yeah. I did that thing I do where I say what the answer is while asking the question. Oops. What do you think those should be called? There's lots. I've heard a couple names. One name is we could call it a minimum, a local minimum, meaning it's a minimum, meaning it is the lowest point in that area of the graph. I've also heard it called valley, like peaks and valleys. But what I'm going to call today is I'm going to call it a trough. Trough. Like a water trough. And if you ever look at waves on the ocean, that's what we call the different parts of a wave. The very top is called the peak of the wave. The dips are called troughs. Sound good? Mm-hmm. So that's where this name comes from. This is the name they actually have in real life. Now, this line running, what's the best way to say it? Now, we're going up and down, centered over this horizontal line between them, yeah? So it's a line that's in the center. What do you think it's called? It's called a center line. So this is the center line. Sound good? Okay, so far we have peaks, we have troughs, we have the center line. Now, a few more things. Now, when we talk about the height of one of these waves, like how tall it is, we compare the center line to the peak. Make sense? So, this distance here is what we talk about when I talk about how tall the wave is. And this distance is called the amplitude.
I know it.
And the amplitude is the distance from the center line to the peaks. Fair enough? Okay, so I need everyone to say that word for me. Amplitude. Okay, really put an emphasis on that P, amplitude. Amplitude, yeah. And amplitude is the height of the wave. Everyone say that for me. Okay, amplitude is the height of the wave. So, now that's a new term, but on Tuesday we learned another term that tells us how long each segment of wave is, how long one cycle is. What was that word? Starts with the P.
Periodic or period?
Period. So you see how we have this one section here that repeats itself over here? The length of each of those sections is called the period. Sound good? And the period is the length of one cycle. Sound good? So, for this sine wave, what is its period? Its period is 2 pi. Starting at 0, ending at 2 pi, its length is 2 pi. This one also has a length of 2 pi. Fair enough? And what is its amplitude? From the center line to the peak, that distance is 1. Sound good? Okay. So now that we have a good, solid understanding of the basics of a sine wave, let's go ahead and tweak this wave. Let's do things to it. Let's see how it changes. So what are some ways that we could change its equation? What's something we could do to it?
Could you insert a degree into X?
Say that again?
Can you insert a number in X?
Let's see, if we
Or
insert
insert a number in front of sign?
Oh, okay, there's an idea. Let's put a number in front of the sign and see what happens. So we're going to have y equals some number times sine of x. What number should we choose?
2.
Start with 2. Seems as good a number as any. So, give it a try. Go ahead and graph both of these. Graph them at the same time so we can see how it changes. I'm going to run around and make sure that everybody has it. Okay. Did you get it working? Interesting. So how did we change? So what changed? Did its period change? So what is the name we have for times? Amplitude. So the amplitude changed it. Like to go ahead and graph sine of 2 or 2 sine of x. So do you guys have the graph? You got it, Sandra? Did you put it up for me? I want to make sure that everybody's equal. So what we're doing is we're going to be doing this first. Go ahead and keep that sine of x, but go ahead and make a second. Let's go down. And do sine of 2 sine of x. 2, yeah, 2 in front of us. Now let's go ahead and grab it at the same time as just the regular unchanged version, so we can see how it changes. So what happened to our graph when we multiplied it by 2? It's going more up, and it's also going more down. Let's do a cylinder. Okay, you got it. Interesting. Yeah. Looks like that's what someone else did. So I want us to start by having sine of x. And we're also doing 2 sine. Oh, you see that one over there on the left side? Yeah, I'll go ahead and erase that. Okay, Kara. So we're doing the stuff there on the right board. I'll go ahead and erase that one on the left. Okay, Selena, you got it? That's y equals. Let's go ahead and go there. Yeah? So let's go ahead and go down, and let's also graph 2 sine of x. Yeah. Guess that 2 is kind of hard to see, isn't it? Okay. Okay, looks good. Now also go ahead and grab sine of x so we can see how it changes. Make sense? So how did it change? It got higher. Okay. So what do we see? So it got. Describe the change to me. What physically happens? Okay, so instead of going up to 1, it's going up to 2. Whoa. Okay, there we go. Something like that. So, did its period change? No, each cycle is still the same length. But what did change? The amplitude. How did the amplitude change? What is the amplitude right now? Okay, so this one, we started with an amplitude of 1, then we had an amplitude of 2. Okay, so what if we have, give me another number. Let's say 3. What if I have 3 sine of x? Okay, I want you, just really quick, before you graph it, I want you to make a prediction for for how it's going to change. Then share it with someone sitting next to you. Then we'll see if you're right. Okay, I'm going to call on someone to tell me what happened.
Class.
Okay. Janelle, how does 3 sine of x look different?
The amplitude makes it 30.
Yeah, now its amplitude is 3. Fair enough. So what's the significance of the number in front of the sign? So the number in front of the sign is equal to what? The amplitude. This number is the amplitude. So if I want to write just an equation that generally shows what sine does, we put a number in front of it, we could probably use an equation like this. Y equals A times sine of x. I'm going to fill in more blanks as we go so we can see what happens. So what does it say represent? The amplitude. Okay, so we tried putting in numbers. We tried putting in increasingly larger numbers. What else could we try?
Could you add numbers to it?
Well, let's hold up on that. Let's keep working with this spot in front of here. But remember that. We'll get back to it later. Okay, so we tried numbers. We tried, going up by, whole numbers, 2 and 3. What happens if we try maybe something smaller than 1? Let's try half. So go ahead and erase your third equation. We don't need too much. We don't want to take up too much space on screen. So let's go ahead and try half. What's half as a decimal? 0.5. So let's try 0.5 sine of x. Now let's see how that changes. Okay. So, what happened? So, what is the amplitude of the wave now? Now its amplitude is half. Fair enough? So it looks like this still works even if we put in decimals, numbers smaller than 1. Okay, what else could we try? Ah, there's an idea. Let's try a negative number. Let's see. So let's go ahead and try negative. Give me a number, any number?
1.
Negative 1. Go ahead and try that. I'm just going to clear off. My graph here. trough, like water trough? Okay. It's British. What do you want? Okay. So a -1. What happens when I put a -1 in front? It's, what do you mean by opposite? It's reflecting. It's reflecting across the center. It'd be interesting to see if it's reflecting across the center line or the axis, because they're not actually the same thing. So it looks like instead of going up, it's going to go down. Okay, so here's a question. What's the amplitude of this wave?
1.
Its amplitude is still 1. The amplitude is just the distance between the center line and the peaks. So its amplitude is still 1. What would the amplitude of this guy be? What would the amplitude of this guy be? How about this guy? Okay. Make sense? And so, let's see. So just remember that negative signs can flip the function upside down. Okay. Okay, so up to this point, we've multiplied the sign, or we've multiplied sign by a number. What else could we try? And well, we already did a fraction. We did a half, didn't we? Okay, well, let's try adding and subtracting. Let's see how that changes things. What number should we add to it? +1? Okay, sounds good to me. Let's say y equals sine of x plus 1. Okay, I want everybody to graph that.
Yeah.
Oh, I'm sorry. You do your best to follow along. I appreciate it. Let's graph both sine of x and sine of x plus 1. Note that that plus 1 is not inside the parentheses. It is outside of the parentheses. Interesting. You can erase some of the old ones. Okay. Okay, so let's go ahead and graph them. Or let's see. All right, you guys already graphed them. Okay, so here's bad job. Okay, so describe to me what happened. It shifted. Where did it move? How did it move? It moved. Well, let me. One to the left. I'm trying to take a look. So how did it move? Where did it just? How did it move? Which way? Up, down, left, or right? Moved up. How far? Well, let's see. Just going to draw what I see here. Okay. So, like that? Is that what everybody has? Is that what you got? Okay. So, interesting. So what is adding? So adding 1 cause it to do what? Cause it to move up 1. Interesting. Okay. So what do you think this will do? Okay, you think that'll cause it to move up by 3? Okay, prove it. Okay. So that causes it to move up how much? 3. Okay. So did its period change? Okay, did its amplitude change? Maybe? What was amplitude again? The distance from the center line to the peak. So where's this? So this one has a center line here. Where's the center line for this guy? Now the center line moved. Where's the center line here? At 3. Ah. Remember, the amplitude is the distance from the center line to the peaks. So its amplitude didn't change, but what did change? What moved? We could say that the center line moved. Make sense? So, we moved the center line. Okay, so we added 1 and added 3. What do you think I would have to do in order to move the center line down? Let's try subtracting. Let's try moving it down by, what would I need to do in order to move it down by 2? Let's see what happens if I subtract 2. Let's see if our prediction is correct. So, were we right? Did it move down by 2? Sure looks like it. So, 1 and 2. Something like that? Okay then. So, we moved our graph up and down. We need a name for this phenomenon, for this thing we just did. Let's see, did we move it horizontally or vertically? Okay, so we shifted it vertically, so we're going to call it a vertical shift. The symbol for the vertical shift, what do you think I should use? Sounds good to me. V. So if I add, if I add a number, what's that going to cause us to do? How will that cause us to shift? Up. So adding causes us to move up. What does subtracting do? That makes us move down. And it is called the vertical shift. So we're assembling a pretty robust little equation here. Okay, what else? So we've multiplied on the outside. We've also done a little division from, dividing by 2 is basically multiplying by 0.5. We've added to it. We've subtracted to it. What else could we do? Well, we did multiplying on the front. Remember? That changed the amplitude?
We add to the degree.
Ooh, there's an idea. We've added on the outside of the sign. What happens if we add something to the inside? Let's give it a try. moment, guys. I gotta check the recording. Okay, so the recording software that I use, it can only record up to 1 hour at a time. It's up to 55 minutes. So I'm going to need to stop and start a new recording. This strikes me as good time as any to have our 5-minute break. So I'll go ahead and set a timer for 5 minutes, and we'll take a 5-minute break while I get the second part of the video up and running. Yeah, you can. Yeah, go ahead. Make sure to sign up and take the pass. Okay, then. I will see you in 5 minutes.